Okay, let's go ahead and get started and test out or try out the Recover web map. So I have navigated my browser to the GIS Center's website. From that home page, I'm going to click on the research link. Now, the first of the active research projects on that page is the NASA Recover project. And from this page, I'm going to go to Results, and then I'm going to start up under Web Services and Connections. I'm going to start up the Crystal Fire demo site. Now, the Crystal Fire was a 2006 fire, and it happens to be one of the largest wildfires to have burned in, let's say, documented or recorded recent history. Now, what you see when you first launch this client web map is the fire perimeter, and that's about the only thing that is turned on by default, just like Bing or Google that you're probably already familiar with. You can automatically pan in different directions, especially once you're zoomed in. This becomes all the more helpful, and you also have a manual zoom, sort of the lasso approach, where you drag a rectangle around the area you want to zoom into. I'm going to go ahead and zoom into this portion of the fire. Now, when we click on this layer list and legend link right up here, this icon or this button, we see a brief or abbreviated list of layers that are available to us from the Recover platform, the Recover Decision Support System. And as you can see, by default, we only have a couple of layers that have been turned on. Well, we also have a layer called Fire Severity. This is a layer that's produced by USGS. And when I have completed looking at this layer, I can roll it back up. If we expand the Recover base layers, these essentially 20 layers or so that we've talked about earlier in the presentation, we see that those layers are all turned on, but the controlling layer above it, Recover base layer, is not. So I'm going to go ahead and turn them on. I've just now zoomed out to the full extent of the fire by hitting this globe button. So right now, I'm looking at aspect. If I turn it off, just like anything else in the world of GIS, this is drawing the layers one on top of another from the bottom of our list to the top of our list. And this is the biophysical setting, a land fire layer. And if we use the Identify tool, here's the biophysical setting. If I want to click on this yellowish color here, I find out that this is Intermountain Basin Big Sagebrush Steppe. Looking at all the historic fires as far back as our GIS records allow, 1936, we see that this region of the Big Desert has a very complex history of fires. Now, I know there's quite a bit of interest in sage-grouse habitat, so I'm going to show you the information that comes up here when we click on a location. This area right here we see is a preliminary priority habitat area, while this is a general habitat area. We also may want some more information. For instance, we can now click on the summary of burned acres by land agency and see a little bit more precisely that the BLM had over 200,000 acres burned. If you want to dig in a little bit deeper still, we can go to the detailed fire report that's automatically generated by the Recover Decision Support System. Now, in addition to all of those layers, we also have available the soil survey based on, in this case, Surgo data. So we're going to zoom into an area of interest, and here we see all the Surgo soils polygons. And that is actually the spatial extent right there on that edge that we're looking at. If we're interested in learning a bit more about a given soil area, we can click on that area. You see it gets highlighted for us. It tells us again that this is map unit 116, which we can read on the map, but we also have a link button right here. And by clicking that link, we automatically get the Ecological Site Plant Association and Vegetation Report for map unit 116. So 116 can then be cross-referenced in this detailed fire report, and we see that nearly 2,500 acres of map unit symbol 116 was burned by this crystal fire. Zooming out to the full extent once again, you may have noticed these green dots. So we're going to zoom in. Now, not every one of the Recover web maps has these green dots in them. This is a good example of fire-specific, extra or special data that has been made available to the end user, actually provided by the end user and made available to them through this decision support system. What this is a UAV or UAS flight over the big desert, following up on some reseeding treatments. We'll grab a couple of them. And again, we see this little orange arrow. So there's a variety of additional tools available at your fingertips. There's a swipe and spotlight tool that allows you to temporarily peel back one layer while viewing another that may be underneath it. There's also a draw tool, allows you to make some measurements as you are drawing. If we measure an area, we see that this area is expressed in a perimeter as well as the area in square kilometers. But if I want this changed to acres, it's fairly easy to do. And there we go, just like that. And you can import a shapefile into this web map just for you to look at some additional geospatial data. Now, if you import a shapefile, that shapefile will be most likely on your own computer. You can view it on your own computer, but it will not be uploaded to the Recover Decision Support System for others to view. If everyone in your agency or everyone working on a given fire needs to see a layer, then it can be added, certainly can be added to this Recover Web Map Decision Support System. That's a real quick tour, and I really encourage you to visit the Recover website and kind of kick the tires